Right, good afternoon, ladies and gentlemen. I hope that you are well fed and well rested. Welcome to the first of the afternoon lectures, where the title is Service Workers in Their Role in the PWAs, which I believe stands for Progressive Web Applications. Please give a warm welcome to Ipsha Bhidonia, who will be presenting today.
Hello everyone, I'm Ipsha. I'm here today as a Mozilla Tech speaker, and I'm going to be speaking about service workers and their role in progressive web apps. So before I start, a little bit about me.
Yes, I'm sorry.
Okay. All right, awesome. Okay, so a little bit about me. Back in India, I professionally work with this company called Gemalto, who, as many of you might know, is into digital security. Parallelly, I also work with Mozilla India as a volunteer and contributor. So I'm really involved with the activities there regarding Mozilla. Okay, so let's start with service workers and their role in progressive web apps. So to start with the role of service workers in progressive web apps, we first have to know what PWAs are. So I'm going to start this with a random poll. So you all have to participate in this, and it goes like something like I will give you two options and you have to select either one of them. Okay, so for example, how many of you would like to have a delicious pizza? Okay. How many of you would like to have a Big Mac? The burger. Okay. Okay, so now suppose if I give you a third option where you can have both a pizza and a Big Mac, how many of you would like that option? All right. So this is what progressive web apps basically are. And I don't mean pizza and burger, but the concept behind that is the same. So you basically are getting a combined version of two equally good options. Only here the two options are the native and the web platform. Okay, so yes, the lifelong discussion between the native and the web and thousands of statistics and comparison data related to UI, accessibility, efficiency, and the never-ending trauma to choose between the two. So why is this such a tough decision? Because, well, not every decision is as easy as this, right? So when we talk about native and web applications, there are basically two parameters that can judge what your application would be in sense of how much user they are attracting, because irrespective of what the use case of our application is, one thing which remains constant with all the application is that we want more and more users to use our applications, right? So that could be measured in two parameters, which is the user's reach and the user's engagement. So when we talk about the user's reach, we are basically talking about how many users have actually accessed your web application or visit the website. However, when we are talking about user engagement, we are actually talking about the amount of time they have spent on your web application. So looking at some of the statistics, think about a situation when you need to get some information quickly on your mobile phones. What do you generally use? You open your mobile phone's browser and you get that information off the website, right? Because you might have native applications for a few things, but you don't have applications for everything, and you would most likely not want to have applications for everything when you can more easily get some quick information off the website, right? So we see that when it comes to user reach, the application is, the web platform is much better at reaching more people. However, when it comes to user engagement, when we are talking about the time spent on a particular application, we see that most people are more likely to spend much more time on a few apps that they really like as compared to say suppose some website that we are just perhaps just browsing through or there to get some instant information. So native applications are much more engaging in that sense, and that's why we see almost 16x time the user spends on a native application as compared to web application. So comparing these two parameters, we see a contrasting pattern between the two. We have the web applications where we have high user reach but low user engagement, and we have the native apps where we have high user engagement but low user reach. So what we get in progressive web apps is a combination of the merits of the two, and we get a higher user reach and a higher user engagement. So that's what progressive web apps help you achieve. Now, what are progressive web apps? It's basically an experience that combines the best of the web and the best of the native. So how do they do that? They use some of the modern web capabilities like providing offline experiences and push notifications to give you a more app-like feature for the user experience. And they basically start from a browser tab, and they eventually evolve into immersive top-level apps leveraging the web's low friction. So this actually helps you to give a better user experience when we are talking about PWAs, because once we start using the web application, when we have that on website, if we use it enough, we get this prompt of adding that application to the home screen. So what this does is basically it gives you an icon on your home screen, and you can just click on it and use it as a native application. So to achieve this, you just need to have a static web app manifest file, which is basically a simple JSON file which gives you, the developer, the complete control of how you want your application to appear in front of the user, where they might expect your application to be, for example, at the home screen. So you have different parameters where you can set the values, for example, being you can set the background color, you can set the icon and the description or the display mode and stuff like that. So once you're done with it, when you add it to the home screen, we get the icon at the home screen, and when you try and click on it, it renders as a standalone mode. Now, having the add to home screen button option is much better than what we were offered earlier, when we were asked to get an application or continue in the application, which basically asked us to download the application to continue to the website. Now, sometimes this could be really annoying for obvious reasons, because you don't want to install an application for everything. Sometimes you just like to visit a lightweight, well-built website, right? So this was one of the things that actually repelled users or customers from your website. And one case in point is about the Google+. So the Google+ found that their download our app interstitial caused 69% of the users to abandon the app rather than download it or even continue to the site. 69% of the users actually saw the link somewhere, cared enough to click on it, but once they saw the interstitial, they said, no, I'm not going to use it. And I'm pretty sure that this is not the only thing on the web that has been going through this. So G+ obviously dropped theirs once they saw the above data. Now, being mobile doesn't mean having a native application and driving people to it, at least not anymore, now that progressive web apps are here. So we talked earlier about leveraging the web's low friction. So how do we do that in progressive web apps? There's this case study that I really like to share, which says that in a consumer mobile app, each step to download an application reduces 20% of the users. So what does this mean for a native application? These are the steps that you go through to install an application. You find it, you click on install, you accept permissions, you download, and then you start using the application. At each step, you're losing 20% of your users. However, when it comes to progressive web apps, you simply find the app and you start using it. So it basically reduces the step between discovery of an app and actually getting it to the home screen to be used by the user. All right, so talking about PWAs, why use it? Because it completely reverses the game plan of the native application. Instead of installing and then using an application, you can first use it, add it to the home screen, and with one click, you can open it. Pretty amazing, right? These are a few examples of progressive web apps and how they have improved the performances. You can look at all these statistics: 2x more page visitors, 74% increase in time spent per session. You can see the data usage has dropped down, 92% less data for initial load, 63% less data, and stuff like that. So when we talk about progressive web apps, what does it actually take for your application to be a progressive web app? So these are some of the features that distinguishes an application and a progressive web application. The first, as the name suggests, it is progressive in nature, which is because it has progressive enhancement as a core tenant, and the experience of the user as they start using the application gets progressively better. Next, it's like it gives you an app-like feel because it is built on something called the application shell. So it distinguishes between the content and the functionality of the application. So even if your entire application hasn't loaded, you have a framework of it on the application. You have the option to add it on the home screen and use it with just one click. It's linkable, means that you can share the application by just sharing one simple URL, and you can start using it. It's discoverable in the sense that it is identified as an application, so the search engines can find it. It's re-engageable because of the push notifications, which keeps bringing your users back to the application. It's responsive and it follows the content is water philosophy, so any form factor, it's there. It's connectivity independent because it's enhanced with service workers to work offline or even on low quality networks. And since we are using service workers for this, and service workers are only served over HTTPS, which means that they are highly secure and ensures that your data is not tampered with. So progressive web apps, in a nutshell, they have this application shell that helps you load the content faster. At the heart of the technology is service worker, which provide functionality like offline experience, push notification, background sync, and then we have app manifest file, which helps us to add it on the home screen, providing a more native app-like experience. So now we talked about service workers being the heart of this entire progressive web app. So let's dive into what service workers are and how they play a major role in what progressive web apps do. So service workers is a script that is run by the browser in the background, separate from the web page for features that don't need a web page or user interaction. Or it is a programmable network proxy or an asynchronous background thread controlling network requests. Or in simple terms, it's something to do with promises, caching, offline experiences, and making the website more like native apps, and doing other cool stuff. So, let's look at what service workers really are. So, service worker is basically a JavaScript file which acts as a client-side proxy server sitting in between the browser and the application. It runs in the background on a different thread to the main JS that powers the app, and hence are non-blocking. Like any other web workers, they do not have direct access to the DOM. They make use of promises and are therefore fully asynchronous in nature. Service worker gives you complete control over how your web page acts in certain situations. So you have the capability of intercepting and modifying navigation and resource requests. You can cache resources and control how your application acts in certain situations, like suppose being in offline mode. So now hijacking connections and fabricating responses is really powerful stuff. And while you might do that for good reasons, the man in the middle might not. So that's why they are served strictly over HTTPS, and they cannot be used in private browsing mode. So looking at the life cycle of a service worker, very quickly, the first step is registration, installation, and then activation. Having a closer look at the life cycle, so once we install a service worker, it could be one of the two cases. Either it's a new service worker or it's an updated service worker, which is found out by comparing the bitwise, comparing the two files bitwise. And if it's an updated service worker, you cannot push it to the activation mode until and unless all the pages associated with the previous service workers are closed. So if they're not, it goes into the waiting state. If it is closed, then you go to the activation. On activation, it's idle until the time that you have certain network request on which subsequent pages might load, and if not, it terminates to save memory. So let's look at how it's done. Starting with the registration of a service worker, we start by checking if the service worker is supported in your browser. Next, we register it with serviceworker.register, which returns a promise that revolves once the service worker is successfully registered. And then we can log the scope of a service worker using registration.scope. So the scope of a service worker determines which files our service worker would control. For example, if our service worker is on the main page, or if it's in the main domain, then all the directories under that file would be served with service workers, and they can be controlled with it. Next, we come to installation. So this is the step where we cache our resources to use later on. So we have our service worker, and once the install event is fired, you go to the network and you cache all the resources that you want to cache. And then, so for the installation, we have caches.open and cache.addAll, where you can add the list of resources that you want to cache. Please note that these are asynchronous operations, so it might be the case that the service worker has terminated before these operations actually complete, which is why we provide an event.waitUntil so that the service worker do not terminate before these operations have taken place. And if any of the files that you list as the resources to be cached fail to be cached, then your installation would not be successful. Next, we have the activation step, which is the idle time to delete the previous cache of the old version of the service worker in case you have an updated service worker. So you can make the changes, and you can find the cache name, and then you can delete all the cache related resources related to the previous service worker. So this is the activation step. Now, these are a few of the use cases that Service Worker provide in terms of progressive web apps. They improve performance by caching network requests and leveraging from the application shell model. They also provide offline access by caching resources, and they provide push notification and background sync. While all these features are available with Firefox right now, we still do not have the background sync, which is under development and should be released in the next release. So let's look at the rest of the use cases. First being the offline experiences. So one of the really nice example of this is Flipkart, which is India's largest online shops. So they have a progressive web app which uses this feature, and they have a really great UI where everything goes gray once you're off the network, so that you know that you're still browsing through, but you are in the offline mode. So if you have previously viewed some of the pages, it is cached, and then you can view it in the offline mode as well. So the general idea behind this is that you have an application and you have a service worker associated with that. So if you're online, you generally fetch stuff from the server. If you're offline, you fetch stuff from the offline cache, right? So we have this module called falling back to the network, which is basically used to improve the performance of a progressive web app. So before going to the network, even if the network is available, we first go to our cache and see if we have certain response for that particular request already cached with us. If we do, we return the response from our cache, and then we try the network. Or in case if we don't have the network, which is where the offline experience comes into play, we first try the cache. If we do not have anything cached for that request, we try the network. If the network is off, meaning we are offline, then we go back to the cache where we must have stored some default behavior that we want to provide to our user in case the application is not running because of network issues. So it could be, again, it could be cached resources, or it could be a default offline page or a game or anything that you want to provide in case the network is not there. So this is basically achieved by adding an event listener to the event called fetch. So a service worker receives a fetch event for every HTTP request made by the browser. So you can add a listener to it, and then you can respond with first trying the cache. If you find a match in the cache, well and good. If you do not, you go to the network. If the network is off, you can just redirect it to one of the offline files, offline.html, or anything that you might have cached in your cache. So this is how progressive web apps basically leverages and gives better performances and offline experiences. Next, coming to the push notifications. So very quickly, what exactly are push notifications? Push notification gets its name from the ability to push information to a user from the server side without the user making an explicit request. So notification can be pushed from the server to the user even when the app is not running, or even when the browser is closed. Why? Because we are using service workers to do this, and service workers run in the background, different from the main thread. So you can have that without having your application open. So web push notification allows user to opt in to timely updates from the sites, and you can efficiently re-engage them with customized and relevant content. So why does push matter? The number one feature is engagement. It helps you get your user back to your application by sending push notification about certain relevant information for the user. It helps in retaining more users, because users are more likely to remain on the app once they get some notification about it by clicking on it. It's strictly permission based, so you can't just send notifications to user without them having accepted the permission. So whenever you see a pop-up message on a website that says, do you want to allow this application to send in notifications? This is that thing. It provides you to give timely updates to your user. There are no forced commitments in the sense that you're not asking your user to give you their email ID or contact information in any way. And you mostly send relevant information which might benefit the user. So what makes the push notification? There are mainly two APIs that comes into play when we are talking about push notifications. One is the push API, which allows the service worker to handle push messages once they are pushed from the server. And the next is the notification API, which generally handles the notification of the message once it is received on the service worker side. So let's discuss the basic workflow of the entire push cycle. There are mainly three components in it. We have a client and a service worker associated with that client, which is the browser. And then we have a push service or a push server. And third, we have the application server. So we'll look into each step one by one. So the life cycle starts with subscribing. So what do we do first is we get the permission to send push notification from the user. So next we subscribe to the push service. Subscribing to the push service basically returns you a subscription object which contains the endpoint URL where you want to push your notifications to, and also the client's public key. We are using the client's public key to encrypt the payload data. Now, once we subscribe to the push notification and we get this subscription object, we pass on this subscription object to the server. And on the server side, it is stored in some database, both the information, the endpoint, and the client public key. So this is how a subscription object looks, which we pass on to the server. So this is what happens at the client side. At the server side, once we have this information stored at the server, and whenever there is some push notification on some kind of trigger that the server wants to push to the user, what they do is they generate a push message, and this push message is encrypted using the client's public key, which was passed on to the server, and then it sends it to the endpoint URL on the push service or the push server. Now next, it is the duty of the push server to route the message to the actual service worker associated with that endpoint URL. So these endpoint URLs are unique URLs associated with just one service worker. So that's how you make sure that your message is routed to the correct place. At the server side, at the client side, with the service worker, once you receive a push notification, a push event is fired, and you can handle how do you want to display that message to the user once the push notification is fired. So the service worker is woken up once the message is received at the client side and the push event is triggered, and we can add an event listener to the push event where you can select how you want to notify the user using the registration.show notification. So this is how the entire workflow of push notification works, and having push notification enabled on your website has shown drastic improvements for engaging a user, as you can see in the following statistics. But having said that, push notifications are a double-edged sword. So while they are useful to engage more users and retain users, it can also drive away the users if you're not using it right, because no one wants to have a lot of notifications drop down on them, right? So one thing that we must always ensure while using push notification is to know how much is too much. So this is it with the push notification side. And this is how it's leveraged in progressive web apps. There's a really cool site called PWAs.rocks where you can go and look at all the progressive web apps. You should really visit it. It's highly recommended. It's really nice, and you can have a look at different domains where progressive web apps are working. Right, so that is it from my side. Thank you very much.
All right, ladies and gentlemen, now it's time for your questions. Ipsha, if you would be willing to answer them, if you look over there. You have it on your screen as well. All right.
Are PWAs working as well on Android than they are on iOS or Windows Phone? So yes, progressive web apps are working really well on Android. iOS, even though they started with providing this feature, they sort of left it behind in the middle. But Android is the one platform which is really going into developing progressive web apps, and we have a lot of latest features, especially for the Android, like even the add to home screen button. Recently, Google has even enabled for the applications to be enrolled in the application drawers and stuff. So yes, definitely it's there for Android. Okay. What is your secret for it? Okay, that question just vanished. Okay. How much data I can put by service worker into the cache? What is the retention basically? So when we are putting data into the cache, it's basically to leverage from the application model of the website. So ideally what we do is we cache the things that we want to show on the first page, even if the content doesn't load. We have this framework sort of thing for your application where you can show different components like the home option or other navigation platform options. So that is the thing, even if it's not loaded with content, it's there. So that is one thing which is cached very often. And the other thing is it mostly depends on you how you want to handle your offline experience. If you want to provide some inbuilt previously determined pages for loading in case of offline applications, we can do that as well. Okay, performance needed. If you compare like 5-10 seconds. Continuousness now. Good. I should not scroll this. Performance needed. I might need a clarification on this question. I don't really.
I think they're asking, will service workers drain the battery on if they're running in the background all the time?
No, service workers won't drain the battery because they are only triggered when an event happens. So when you get some HTTP requests, service workers are woken up only then, since they're running in the background. So it's not likely to drain much of your battery, as you have triggers and you add event listeners to that particular event. So it's mostly functional in those cases. So no. Name a few things we cannot do with PWA in compared to native app to understand better what PWA is not good for. Okay, so one thing that native applications can do, which progressive web apps cannot do, is basically be present, be well integrated with your Android. Like you can find the application everywhere, even in the app drawer and stuff like that. PWAs are not present there. It is under progress and under development from Mozilla side, but I think this is one thing that PWAs cannot do right now with Firefox. Okay. Okay, I'm not really sure about the last question. What is your secret for the nice draw icons of your presentation? My secret for nice draw icons is, I don't know, I'm good researching, I think, because most of the thing that I used can be found online. And even though I did make some of the flow charts and stuff like that, but most of it can be found online, so it's not on me. Yeah. I think that is it. I'm not really sure about this question, so I think I'll pass this.
So can the person clarify the question? Yeah? I'll give you the microphone, please.
Thanks. Well, I meant with React Native, or React Native seems to me like it is one service worker on a background, because it's basically a JavaScript code that just sends some information to the front layer, to the native, basically the native layer. But all the logic, or most of the logic, is on a background on some JavaScript engine. So it seems to me like it's similar to the Power Web App, but what you get from React Native is the compiled package, which you just publish the classic way on a store. So it's not, obviously not a Power Web App. But is there any relation between the Power Web Apps and React Native?
So I think if React Native are using service workers as well, then the majority of the things are similar between PWAs and the native thing. But again, the difference lies in the entire installation part and how they are used, because we have this reverse clean time for PWAs where we use it first and then install it. So I think that is one part where PWAs get more handy and provides better user experience. But talking about service workers, I think it is handled in a similar way.
Thanks.
There is a need for fresh search data on analytic to create audience, etc. Okay, a good example of an offline web app. So we did talk about AliExpress and other online shop portals where we can use this. It's on Medium. Suppose if you want to read some article and you don't have connectivity, you can do that. One really good example of offline web app, which I feel is really useful, is what Air Berlin has done with their application. So when you're traveling, you don't always have data, right? Especially when you're traveling abroad somewhere. We are very conscious about the data and how we are using it. So Air Berlin provides you this offline feature where you can check all your flight details and everything related to your booking without having data connectivity, which I think is very useful.
All right, that was the last of the questions. So thank you very much, Ipsha, for your presentation. And if you want to talk a little bit more and delve deeper into the issues, I'm sure that Ipsha will be in the speaker's corner on the corridor. Thank you very much.